Okay, so in this video we're going to go through some vector questions, and we're given all these questions and all this information. So find AB is our first question, and it's the vector AB. So we're given that A is -2, 4 and 7, and B is -1, 3 and 8. So how do we find AB? Well, what we can do is we can say that AB is B minus A. So that's the destination vector minus the origin vector. So let's put that up there now. So we've got -1, 3 and 8 minus A -2, 4 and 7. Okay, right, now it's just simple mathematics. So we've got the X, the Y and the Z. We just do the subtraction, see where we end up. -1 minus -2. So that gives us +1. So we've got a 1. 3 minus 4 is -1. And 8 minus 7 is +1. So then that gives us our I, our J and our K. So when you're doing vectors, for your I, J and K position vectors, you need to underline them. Okay, so AB, which is a direction, we've now got, so the answer to this one, we've got I minus J plus K. Okay, and then we can keep this vector here, 1 minus 1, 1. We're going to need that. We'll just leave it there for now. Okay, vector equation for line 1. That's part B. Line 1 passes through A and B. Okay, right. Let's just draw a picture of what we got here so far. So A and B look like they should make this kind of shape. Maybe the B is here, and they go from there to there. That could be our vector AB. And A is -2, 4, 7. And B is -1, 3 and 8. Let's just okay, so there's what we got so far. And L1 will pass through AB, so we could call this line here L1. So that will go off there, go down here. We just call this L1. Okay, so vector equation for L1. So we know it passes through AB, and so we got the 2 points on there, but we also need the direction, which is this vector. So what we say is that L1, so we need to write this correctly. So what we say is L1, call it R, equals, so when we do that, we're ready to set up now one of the beginning points. Now you can put either of these two, it doesn't really matter. I'm just going to choose A. So -2, 4 and 7. Okay, that's our beginning place. And then what we're going to do, we're going to add lambda, which is our coefficient, and then we're going to use this as our direction, because it will always move in this direction for wherever you are. So lambda 1 minus 1, 1. Basically that's our vector equation for L1. So I'm going to write that down on here. So that's that one. Part B, is L1 R equals minus 247 plus lambda 1 minus 1 and 1. Okay, just fit in there just nicely. So that's the answer to part B. Right, next question is find theta. Now we know the angle theta is P, B and A. So it's going to be somewhere here. So we've got B and A, but what do we know about P? So P equals 0, 2, 3. Okay, so how are we going to find out where P goes? So P is 0, 2, 3. So P will be somewhere down here. We've got less than these, less than these, and less than these. So we go all the way down. So let's just put that down here somewhere here. So let's make that a bit more a straight line. Okay, that gives us P. And P is 0, 2, 3. That's our point point P. And so therefore PBA, so this angle here is going to be theta. So how are we going to work out theta from there? Well, using the cosine, we can say this line multiplied by this line and then divide by the absolute values. So let's just write that down in a little bit more understandable language so you can see that. So cosine of theta, so that equals PB or BP, it doesn't really matter. So we call it PB times BA or AB. Now we have got our AB here, so let's put AB. So always good to use the information we've already got. And then we divide these by the absolute values of the vectors we got in the numerator. And then we multiply them up. Okay. Right, that looks a little bit crazy at the moment, but we can soon work that out. So PB, what is PB? Well, for a position vector, PB, we basically just take B from P. So let's just advance on that a little bit more. So PB. So if we do just quickly in our heads, P to B, so we take B off P. So 0 minus 1, that gives us 1. 2 minus 3, that's minus 1. And 3 minus 8, that gives us minus 5. Multiplied by AB, which we know is 1 minus 1 and 1. Okay, don't miss the minus sign in there, very easily missed. Okay, so absolute value of PB. So absolute value of PB, so that's going to be absolute value of this and absolute value of this for AB as well. So what we do for that, we do square root 1 squared plus minus 1 squared plus minus 5 squared. Okay, and then multiply that by square root 1 squared plus minus 1 squared plus 1 squared. Okay, how are we going to get this one? So how do we multiply that up? So we just multiply each line, then add up the totals. So just put that on the side here. So actually we'll go on the side, we'll go back down here, that's absolutely fine. 1 times 1 is 1. Minus 1 times minus 1 is also plus 1. And minus 5 times 1 is minus 5. Okay, so we've got that. Now what we got? Square root all these in here. So square root 1 squared minus 1 squared, well that's 1, minus 5 squared is 25. 1 squared, minus 1 squared and 1 squared, they're all 1s. So add these up. So we've got square root of 27, square root of 3. Okay, so now what we can do is 1 plus 1 is 2, and minus 5 is minus 3. Okay, then 27 as a third, we could say that is 3 root 3. And root 3 here. Okay, so minus 3, and 3 root 3 times 3 is 3 3s are 9, because root 3 times root 3 is 3, times 3 that's 9. That's minus 3 over 9. And as it's cosine, we can also say that minus 3 over 9, because it's cosine theta, we can also say it's also 3 over 9. So therefore that equals, we'll just call it 1/3, or minus 1/3. Okay, so find theta. So cosine theta. So cosine theta equals 1/3. Okay, that's good. So that's that sorted. Vector equation for L2. So what do we know about L2? Let's get a better pen. L2. L2, C and D line on the line L2. L2 passes through P and is parallel to L1. So we're going to be parallel to here. And this is L2. And vector equation for L2. So what we do know is that the direction of L2 is the same as L1. We know that P is also on it. So we can basically do something similar to this one here. So what we can say is that L2 R equals point P, which is 0, 2, 3, plus lambda, and then direction is the same as L1, so that's 1 minus 1 and 1. So that's our vector equation there. So let's just write that in. So we can say, let's get the terminology in there. So L2 R is 0 to 3 plus lambda 1 minus 1 and 1. I'll just squeeze that in there, just somehow. Okay, so we can see the answer. Okay, that's all good. Now find the coordinates of C and D. C and D lie in L2, and the x-coordinate of C is positive. So here we go. There's P. So C and D are on L2, and x-coordinate is positive. Right, okay, so we'll have C here and D here. So how do we find the coordinates of C and D? Well, AB equals PC equals DB. So AB equals PC equals DP. So these lines are all the same length. There to there, there to there, and let's just squeeze out up there for now. Okay, so they're all the same length. That's something we know. So how are we going to find out the coordinates of C and D? Well, we know what P is, and we've got the vector equation for L2, so that's this line, and P and as D, P and C all sit on that line, we can use this equation here to find it. So if we take 0, 2, 3, that's our point P. If we're going up, we'll add this lambda here, which I've also got in here, which is a little bit squozen in, but it is what it is. Minus 1 and 1. That equals 0 plus 1 is 1. 2 plus minus 1 is 1. 3 plus 1 is 4. Okay, so we can say C is 1, 1 and 4. And then D, which is going down the other way, so then instead of the positive we put the negative. So then we get 0, 2, 3, minus lambda, 1, minus 1 and 1. So that gives us 0 minus 1, minus 1. 2 minus minus 1 is 3. 3 minus 1 is 2. Okay, so therefore what we can say is that coordinates of C is 1, 1, 4. Coordinates of D is minus 1, 3 and 2. Or we could write C is 1, 1, 4 and D is minus 1, 3, 2. Okay.